everyone, thank you so much for clicking onto the video. Today's learning objective is to understand, in terms of changes in oxidation number, the following reactions of the halogens. So firstly, oxidation reactions with group 1 and 2 metals. Secondly, the disproportionation reaction of chlorine with water and the use of chlorine in water treatment. Thirdly, the disproportionation reaction of chlorine with cold dilute aqueous sodium hydroxide to form bleach. Fourth, the disproportionation reaction of chlorine with hot alkali. And finally, the reactions analogous to those specified above. So now we're going to talk about the use of chlorine and chlorate 1 in water. Now, chlorine reacts with water in a reversible reaction to form chloric acid, which is the HClO, and hydrochloric acid. So chlorine reacts with one molecule of water, and this forms the chloric acid and hydrochloric acid, and this is the reversible reaction. And this is also what we call a disproportionation reaction. And what that means is that an element has been oxidized and reduced. So if we work out all the oxidation numbers that we have, so the oxidation number for chlorine in a chlorine molecule is 0 because it's an element. And then we have oxygen and hydrogen, which are -2 and +1. And then on the other side, we have HClO, which is a bit of a strange one because we have oxygen with -2 and hydrogen with +1. And so chlorine is actually a +1. So we have hydrogen is +1, chlorine is +1, and oxygen is -2. And then for the hydrochloric acid, we have hydrogen, which is +1, and chlorine, which is -1. And so what's happened is that chlorine, you have chlorine, which has an oxidation number of 0, chlorine, which has an oxidation number of +1, and chlorine, which has an oxidation number of -1. And that means that chlorine has undergone disproportionation, because to get from chlorine to this chloric acid, the chlorine has undergone oxidation because it's lost an electron to form a +1 ion. However, to get to the hydrochloric acid, it's been reduced. So because the chlorine's been both oxidized and reduced in the same reaction, we call this a disproportionation reaction. And so this reaction of chlorine with water happens when we use chlorine to purify water for drinking and also in swimming pools. And how it does this is that the chloric acid is an oxidizing agent, and so it kills all the bacteria in the swimming pools by oxidation. However, a different reaction happens in the presence of sunlight, and we get chlorine reacting with water to form hydrochloric acid and oxygen. So when there is lots of sunlight, the chlorine actually gets used up really, really quickly because it's no longer a reversible reaction. And so we have to keep on topping up the chlorine if it's an outdoor pool, for example. So an alternative way that we can sterilize water is to add solid sodium/calcium chlorate 1, and this dissolves in the water to again form the chloric acid in a reversible reaction. So we have the sodium chlorate on the left reacting with water, and then this is in a reversible reaction with sodium ions, hydroxide ions, and also the chloric acid. And you can also see that if we put this in an alkaline solution, that means that we'll have a surplus of the OH- ions, and the equilibrium will shift to decrease this surplus of OH- ions, and so it shifts to the left. And so the chloric acid is removed as ClO- ions. So because the equilibrium has shifted left, that means that there is more of the chloric acid which is being used up to form the sodium chlorate and water. And so this is why pools actually need to be kept slightly acidic, so we can keep this equilibrium to the right, so then more of the chloric acid is formed to sterilize the water. Now, society assesses the advantages and disadvantages when deciding if chemicals should be added to water supplies. However, the benefits to health of water treatment by chlorine outweigh its toxic effects. So now we're going to discuss the reaction of chlorine with sodium hydroxide. So chlorine reacts with cold dilute aqueous sodium hydroxide to form sodium chlorate, which is NaClO, And this is an oxidizing agent, so it kills bacteria by oxidation, and it is the active ingredient in bleach. So the thing you need to remember is that it has to be cold, dilute, and aqueous sodium hydroxide. And then the equation that we have is that chlorine reacts with 2 moles of sodium hydroxide to form this sodium chlorate and sodium chloride and water. And this is also a disproportionation reaction. So again, if we work out all the oxidation numbers, so for chlorine here we have 0, and then for sodium we have plus 1, and then for oxygen we have -2, for hydrogen we have plus 1, and then for we've got sodium, chlorine, and oxygen. So chlorine is -2, oxygen is -2, sorry, sodium will be +1, and so chlorine must be +1. And then we have sodium and chlorine, so we have +1 and -1, and then hydrogen and oxygen would be +1 and -2. And so you can see that we go from chlorine 0 with an oxidation of 0 to a chlorine with a +1 and a chlorine with a -1. And so again, we have oxidation and reduction happening at the same time in the same reaction. Because to get from the chlorine to this sodium chlorate, it's being oxidized because the oxidation number is increasing, so it's losing electrons. And to get from the chlorine to the sodium chloride, we're reducing it because the oxidation number has decreased, so we're adding electrons. And so because it's being oxidized and reduced at the same time in the same reaction, that's why we call it a disproportionation reaction. Now we're going to look at some questions. So for question 1, write an equation for the reaction between chlorine gas and dilute aqueous sodium hydroxide. Name the 2 chlorine-containing products of this reaction and give the oxidation state of chlorine in each of these products. So this reaction is really, really important to remember because it's just, it always comes up as a sort of recall question. So what happens is that chlorine reacts with sodium hydroxide, and this goes to form sodium chloride and sodium chlorate and water. And so we have this as sodium chloride, and this is sodium chlorate. And we could also put in the oxidation number of the chlorine, which is 1. So it'd be sodium chlorate 1. And then now it says to give the oxidation states of chlorine in each of these products. So chlorine in NaCl would be -1. And then in this sodium chlorate, we would have oxygen as -2, sodium as +1. And so for all the charges to equal the overall charge, which is 0, the chlorine must be +1. Before I move on to question 2, feel free to click off the video and try it for yourself first. So write an equation for the reaction that occurs when chlorine is added to cold water and state whether or not the water is oxidized and explain your answer. So again, this is another recall question. So with this whole topic of inorganic, it's quite good to remember all the equations and what everything produces and all the equations, because lots of these questions that come up will be simple recall questions. So you either kind of know it or you don't. So it's better just to memorize them all. So what happens is that chlorine reacts with water, and this forms hydrochloric acid and HClO. And then state whether or not the water is oxidized and explain your answer. So if we have a look at all the oxidation numbers, so we have chlorine here is 0 because it's an element. Then we have oxygen and hydrogen, -2 and +1. And then here we've got hydrogen and chlorine, +1 and -1. And then here we have hydrogen, chlorine, and oxygen. Hydrogen is +1, chlorine is +1, and oxygen is -2. And so we can see that the water is not oxidized because the oxidation states of this O2 minus and this H1 plus do not change. And so that means that the water is not oxidized.